Okay, back by popular demand. Linear amplifier repair for mud ducts part 2. This one is only going to be a very basic run through on keying circuits and relays. That's going to be it for this lesson. So anyway, all linear amplifiers use a relay of some kind of some sort. Some use vacuum relays for the expensive better ones, but most CB amps, especially not the big ones, but the medium and small ones, they all gonna have a relay or two or five in there for like a phantom, some phantoms or something that do various things. But I'm going to concentrate today on the smaller amps, especially ones with a single relay and the keying circuit. And I'm using this little DNA Hawk for demonstration purposes, and also before I get going good, this Hawk runs on a separate power supply. I kind of use it for a tester to test baldies, and there's no high voltage, not even a plug-in voltage, AC voltage going into this at all as far as high voltage or plug-in. What I have to run this is 13 volts off a little 2 amp power supply, that little variable guy there, and that's limited to 2 amps, and you can limit it, current limit it down more than that, and that's what's running this, gonna run the relay for this only. So I can stick my fingers in there and wires come off or whatever. I don't have to worry about getting shocked or electrocuted, because again, there's no high voltage at all to this, no high voltage capacitors, not even an AC plug coming into this or AC power at all. I just got the 13 volts limited at 2 amps. And by the way, even if you got a 13 volt power supply, if you got a big 50 100 amp power supply, don't do that to run relays or something. Well, if you do, put a fuse in there, because you get your wires crossed or you get a short. I'd hate to have somebody have 100 amps or 500 amps going through these things. So that's my safety speech. So don't do this at home. Again, this has no lethal or shocking voltage going through it at all. Just 13 volts at 2 amps for this demo. So anyway, that's the relay in that one. A little 3-pole double throw relay, and I'll explain that in a second. 12 volt relay, 12 volt coil. And here goes some relays I kind of pulled out over here. I just pulled this bigger one out to start with. See the third line down where it says coil 12 volt DC? That's to run the relay, to make it energized, to make it work, to turn it on. You need 12 volts DC across the coil to make this work. Well, I hope I don't get the coughs. They got AC relays, they got high voltage relays. An example of the high voltage is, this is a relay off a Tram D201. And where are you? I saw you somewhere. And the coil at the top, or the coil on this, runs on 115 volts. You see that top? And X6, this one is a 6-pole relay, 115 volt, which are, 115 volt high voltage relays are getting obsolete. They were made more for tubes, but the Tram D201 was a tube radio, and it used this relay here. And it's getting quite expensive and hard to find, and it's got 6 poles or contacts, whereas most amplifiers have 3 poles, like this one, or 3 sets of contacts. Camera there, 1, let's start at the top, 1, 2, and 3. That Tram one had 6. This big one here had 3. And then just for visual purposes, I guess, this one here has 2 contacts. This is similar to what they use in that Browning 180 and some others, and they use a little cheater connection to turn the amp on. And why you need 3 contacts. And these are all double pole, double throw, meaning that they got to simplify it, they got a contact when the relay is not energized that's connected all the time, and that's what be these upper 3 contacts. And then when the relay's energized, it's got, you know, a contact underneath. So when the relay is keyed down, or I'm pushing it in for visual, it's connected to the bottom contacts and disconnected to the from the top contacts. And that's what they mean by double pole or double throw. That you have, you know, one contact is connected when it's not energized. That would be normally closed because it's closed when it's not energized. And then the ones underneath, in this case, they're not connected until it's the relay is energized. They're normally open because it's not connected when the relay is not energized. And normally closed is usually abbreviated NC if you see it in the schematic, and normally open is NO. So that's what that means. And I've had quite a few comments, people talking about the relay itself sticks. That, you know, they've seen relay sticks. I've never really seen that. I just kind of went along with that. If the relay was sticking, like I'm pushing it in on it now, it'd take a heck of a lot of stickum to make that thing stay stuck. You know, I'm pushing it all the way down, and you know, they're like, somebody sprayed some spray in there and it gets stuck down. I've never really seen that. What makes a relay stick in an amplifier, I have seen where it arced and the contacts got shorted together. But when that happened, it stayed stuck all the time. It wasn't going up and down like this one. It was stuck in the down position. I've seen that. But I haven't seen one that, you know, intermittently or randomly sticks because it's got spray in it or whatever. You know, I can spray that all day long, and that thing's not going to stick. What happens when you run it in an amplifier and the keying circuit leaks? The keying circuit to keep it closed because the keying circuit is leaky, and you know you're getting voltages that you aren't supposed to get, and the keying circuit's messing up, and that'll make it stick. And another way you can tell if it's the electronics or the keying circuit, if you had it running and it was sticking, you turn the amp off. That removes all the power off the thing. Then it unkeys. That means it's the electronics making it stick, not the, you know, mechanical relay itself to stick. And so that's one way. And I think what I'm doing right here, I'm pushing down on the thing, it goes down. I lift up, it goes up. This relay is not sticking. So that's another way to find out, you know, if the relay is sticking or not. Let's push on it, see if it releases, comes back to you. You know, like that. It's not sticking. And then do this carefully. Again, this is unpowered. This stuff, I got 13 volts running there, I think. You know, no high voltage, not plugged in, no nothing for it. So, you know, be safe out there. But anyway, most CB linears run on a relay that's a 12, 13 volt relay. And here's a simplified, very simplified schematic I drew of the contact part. And I just did the in and the out. Here's a basic schematic of the radio coming in. That's your coax connecting right there. And it goes through a wire into the common pole of the relay, and then the relay is connected to that top one that normally closed. This would indicate the switch of the relay, and it's connected to that top one. Then that's just a loop around to the other pole of the relay, the other top one, you know, in this case, and I'll get back to that in a second. And then through the common pole of the output side of the relay, and then your out coax or your antenna coax right there. So basically, when a relay is unkeyed, you know, no power going to it, it goes in through the coax, through a little wire, into the one pole of the relay, it's normally closed because it's not energized, and it goes through the loop, and then it goes out to the antenna. And basically this is it. Which one's in? This is the end coax, goes into a purple wire, and that goes down underneath, but it goes to that connection right there, and then this is the other side of that connection. It goes around to that normally closed contact. It's connected to that upper one right now, and it goes round through the loop, and then it goes back out around through the contact, and then back out on the other side to the antenna. So it just comes in, loops around, and goes out when it's not keyed. And if everything's working right, and I haven't messed up that relay, and I got it hooked up to a radio and a dummy load. Oh, I got it keyed down. Let me put it in standby. And there we go. I got 3 watts from the radio here, 1.3 SWR. It's 1.3 because it's going through the radio watt meter there. I think that thing there. And then it's going through this thing here. And then it's going out to the watt meter and then a dummy load. And that's why the match is 1.3. It's so much stuff in line. But anyway, I'm getting 3 watts out. 1.3 SWR, right? So I'm going to turn the amp off standby and key it down pretty quickly. See the relay clicking in? No sticking. Little bit of a delay because DNA on this amp, there's no SSB button or switch. So it's got like a semi SSB. It's got a little bit of a delay, so the relay is not real quick. So it's kind of like slowed it down enough for maybe SSB. And you can run either AM or SSB off this amp. But if you wanted a more delay, you could put in a larger cap, like the Browning Ping. But anyway, reason I'm keying down quick is because I'm keying down now, and those watts, instead of looping around or going out with that relay kicking in, those watts now, when it's keyed down, that switch there, or that contact of the relay, goes down to this one. That's the bottom one it connects to. And it goes into the tube, and that would be your drive power, right? I ain't got no tube in this. And when I key down, my input SWR is 8.5 to 1. And that's what happens when your drive, for some reason, is not, from the radio, it's going through there, and it's not making it into the tube. I don't have a tube in this, so that drive is going to nowhere, basically, and that's why my input SWR, this meter is hooked between the radio and this amplifier here. That's why it jumps so high now. That's my input SWR, and I keep it keyed down like that for too long, it's going to blow the final in my radio. If I put the tube in there, my input SWR would go down probably substantially. And then if I powered it up and all, my input SWR would go even lower. But this amp doesn't have a tuned input, so it wouldn't go too low. But I say, check your input SWR all the time. If you got no watts, if your input SWR is high, like that, those watts are not making it to where they're supposed to be. Something's wrong. So you start with, tracing that. And often, if your relay is keying down, like that one is, and your input SWR is high, it's often a dirty relay. Those contacts get dirty, and CB amps are around 50 years old now. 30, 40, 50 years, right? So those contacts get dirty and carboned over and all that, and a lot of times if your watts aren't making it in with a high input SWR, your input contact on the relay is bad. And a lot of times if your amp seems to be doing everything, tube's getting warm, supposed to be putting out, but it ain't putting out nothing. A lot of times your output side of that relay contact is bad. Remember to loop around, and when it's keyed down, that goes from there, it's connected to there, your drive goes in. This is a quick schematic of a tube. That's the tube power coming out with no tank circuit or nothing in it. That's simplified. And it's power out. This is key down again. And then it goes straight out. But if this contact or this one is dirty, or not making a good contact, your input SWR is going to be really high. If this one is dirty, not making your contact, that tube's going to be really hot because it's putting out power, but that power ain't getting out because you got a bad contact here on the relay. That's a very common problem with amplifiers. A main one is the relay there. Also, I'm going to go right quick through how the keying circuit works. This is very simplified, right? Most CB amps run on 13 volts or so. Some I've seen 15, 18, 20. I've seen some DNAs with negative volts, so be careful of that. And tube amps, they run at like 100 volts, usually 100, 120 volts on the relay, so be very careful with tube amps. But anyway, most amps, probably 95%, run just like this. You got 13 volts coming off the DC, coming off the low voltage power supply. Usually goes into the standby switch first, so when got the standby switch in standby, you got no voltage going to the relay, so no key down, everything's happy. You turn the standby switch on, now you got voltage going in, 13 volts through the relay, and this over here is the ground side of the relay, right? And even though this is a switch, that's a schematic representation of a switch, that's basically what the keying transistor does. Even though it's a transistor, and I know this is not a schematic of a transistor, but in effect, that's what a transistor does in a keying circuit. It acts like a switch. When that transistor sniffs the power coming in when you key down, it activates and it basically closes that switch. And the other side of that wire there, it goes straight to ground. So it closes the switch. Now you got ground on this side of the relay. The relay coil. And then you got your 13.8 or whatever voltage on this side of the coil. So the coil, which is a magnet, energizes. It pulls that rod, or I forgot the proper name, getting old, but it pulls that rod down, it pulls the contacts down, and it makes your switches close. So that's how that goes. And usually what happens is that transistor gets bad, starts shorting or leaking. You're going to have some kind of power leaking and going through here. And that's going to keep the relay closed or make it close longer or close all the time. And usually the problem when you have a amplifier where the relay is staying closed is either that transistor, or sometimes you get some feedbacks and oscillations and harmonics in the amplifier that's not good, that you're not supposed to have. That amplifier, is doing funky things, or is funky design, funky parts, whatever, bad parts. And those harmonics and feedback watts and all that you're not supposed to have are feeding back into the input circuit. And that input circuit is like, hey, I still got input, so I'm going to still key the keying transistor because, I'm sniffing power that's leaking and I'm not supposed to have. So I'm going to key the keying transistor still, and the keying transistor stays energized. So that's how that happened. Again, you turn it off, the thing unkeys. Is something with the electronics. It's not the relay itself. So for the most part, clean your relay. And also, if something goes wrong where it's not keying up at all, or it's staying locked up, often that's the keying relay. Keying transistor, I'm sorry, not relay, keying transistor. And there are many, many different types of keying transistors. I think Palomar uses a 2N 2905. Black Cat uses a 2N 2222A. I forgot what DNA used. Some DNAs had tube ones. Looked like that one's a 2N 2906. But it's all types of different keying transistors used, so I can't tell you, exactly what amp and whatever. So, get you a schematic. Look it up on cbtricks.org. But main problems with keying transistors, again, not getting power. Often it's a dirty relay. Not keying it up. It's usually the keying transistor. Staying locked up. It's again usually the keying transistor, or you're getting a funky harmonic, bad feedback or somewhere, and that feedback is locking up that keying transistor, which is locking up the relay. So anyway, I hope I made it simple enough. 13 volts into that coil, standby switch. You should have your proper voltage at the coil with the standby on, and then that side puts a ground on it. I often, because I know I got 13 here and I know that's the ground side, I can ground out that ground side with the jumper and the relay should key, but that's kind of getting a little advanced. If you're not sure what you're doing, don't do that one, but that's the real basic thing of a keying transistor and our keying circuit. And one thing I've missed with the relay, most CB amps have a 3-pole relay again. And they got, one in, then through the loop, then one going out. And then that third one is when it keys the relay, that keys the voltage or activates the voltage or something in the amplifier to let the tube loose. It may go to a ground where the ground or cathode on the tube, needs to be grounded. It may go to that. If it's a turbocharged tetro, they may switch the screen. I've seen some amps run high voltage through there, which is not a good idea, but some amps, some of the designers, some of the engineers, what's that one? BLJ? I think BLJ is one that does that. They send the high voltage right through the relay, and if that high voltage arcs, and that's the input side of your radio there, that high voltage arcs over here to your radio, you just blew your radio. So it's never a good idea to run high voltage through that, but some do. But anyway, they use that third leg to key the amplifier down, and sometimes that leg gets dirty, the one that runs the voltage in the amplifier when you key down, and then that's why your amplifier ain't doing nothing. Sometimes that controls the bias from, standby bias to key down bias. And again, if that's not connection, you're not getting the proper bias, the amplifier won't go. But anyway, relay, bad, common problem of why amplifiers won't work. It's one of the first things I start with is take apart and clean that relay. All right, I think that's going to be it for this one. Hope it helps somebody. Hey, don't kill yourself. High voltage tube amplifiers have high voltage and they're dangerous. Bye.